Good morning. We're going to start our training today by talking about backward design. What is backward design? It is a method for planning lesson with the focus on the end product. As educators, we cannot decide which materials or methods to use during instruction until we have pinpointed specific concepts and skills we want our students to learn. The idea of backward design is to teach toward the end point or learning goals, which typically ensures that content taught remains focused and organized. This in turn aims at promoting better understanding of the content or process to be learned for students. The educator is able to focus on addressing what the students need to learn, what data can be collected to show that students have learned, and the desired outcomes, and how to ensure the students will learn. Our objectives today. We're going to define the 3 stages of backward design, and we're going to try to implement backward design in one of our 6th grade math lesson plans. So to start, we need to identify the stage. Stage 1 is identify desired results. What should students hear, read, view, or explore, or otherwise encounter? What knowledge and skills should student master? What are big ideas and important understanding students should retain? In the first stage of backward design, we consider our goals, examine established content standards, and review curriculum expectations. We have to be able to do the following 4 criteria if you want to identify the desired results. 1, what prerequisite knowledge is necessary for successful learning to occur? 2, teachers need to consider whether the subject matter will extend into the real world. 3, teaching for understanding is critical when uncovering focusing topic. 4, ideas used to engage students in a way that connects to students' interests. Basically, for the purpose of today's training, for stage 1, we have to be able to establish the goal. We have to identify what TEKS we're going to teach. We have to understand the desired outcome. What is it that students will understand? Students will understand what? You have to come up with some questions to guide students' inquiry and focus instructions for uncovering the important ideas of the content. And last, you need to identify the key knowledge and skills that we want students to know and to be able to do. Students will be able to do what? Stage 2 of backward design is to determine acceptable evidence. How will we know if students have achieved the desired results and met the standards? What will we accept as evidence of student understanding and proficiency? How do we know if a student has succeeded in what we want them to learn? Okay. Backward design encourages teachers to first think like an assessor before designing a specific lesson or unit. When planning to collect evidence for understanding, teachers should consider a range of assessment, and these could include an informal check of understanding, observation and oral questions, quizzes and tests, open-end prompts, maybe a performance task or projects. These are all different type of assessments that we can use for stage 2. On stage 3, the fun part is planning the learning experience and instruction. With clearly identified results and appropriate evidence of understanding in mind, teachers can now plan instructional activities. When planning, teachers must think about these key questions. 1, what enabling knowledge, facts, concepts, and principles and skills will student need to perform effectively and achieve desired results? What activities will equip students with the needed knowledge and skills? 3, what will need to be taught and how should it be taught? And 4, what materials and resources are best suited to accomplish these goals? And 5, is the overall design coherent and effective? Okay, so now that we know the 3 stages of backward design, let's go ahead and practice implementing backward design on one of our 6th grade TEKS. So what I decided was 6.8, the student applies mathematical process standards to use geometry to represent relationship and solve problem. And this is just a cute little picture that my son showed me. He's currently moving towards 6th grade. As you can see, it has the little X and it says find X, and here is X. Something that my son thought was funny. So stage 1. So when we're writing the backward design using that TEK, remember in stage 1 you want to identify desired results. Okay, students will understand how to what? In this case, it's students will understand how to model and solve area formulas for parallelograms, trapezoid, and rhombus by decomposing and rearranging parts of these shapes. Now, as you recall from the beginning of the training, I told you with desired results, you have to have the understanding. Students will understand that. And again, in this case, I use examples. Students use symbols, geometric labels, precise language to determine and describe the area of parallelogram, trapezoid, and rhombus. So under the understanding, you want to be able to specifically, do you want students to understand? What is it that you want them to understand? And then remember, we talked about essential questions. Student will keep thinking about what thought-provoking question will foster inquiry. And for this example, for this TEK, I wrote, what is the area of trapezoid? What ways can you form two triangles using a trapezoid? And how are the area of trapezoid and the area of parallelogram relates? So again, this is a framework for backward design, and this is only on stage 1 where you are desiring results. And under stage 1 still, students will understand how to model and solve area formula for parallelogram, trapezoid, rhombus by decomposing and rearranging parts of these shapes. Not only do you need to know the understanding and the essential question, you also have to have the knowledge. Students will know what is it that you want students to know? What facts and basic concepts should student know and be able to recall? And in my example, for this TEK, it's formula for area of a trapezoid. This is what students will know. And of course, the last thing for stage 1 is the skills. Students will be able to do what? What discrete skills and process should students be able to use? And the example, they will be able to look at a picture of a trapezoid and find the area of two triangles, or find the height of a trapezoid. Again, this is just an example that we're using right now based on one of the TEKs. Okay, so remember stage 2 is the assessment part, determining acceptable evidence of assessment. Okay, so what I have decided to use, and remember there's all different types of assessment, I decided to use a quiz and questioning. So under the quiz, as you can see, a parking lot in the shape of a trapezoid has an area of 12,052.1 square meters. The length of one base is 82.4 meters, and the length of the other base is 108.6 meters. What is the width of the parking lot? And then the questioning, you are given a formula and told that if it is a formula for the area of a quadrilateral, can you tell whether it is a formula for the area of a rectangle, parallelogram, trapezoid, or rhombus, and explain your reasoning. Again, I chose 2 assessment. Remember, backward design, you are assessing first before you actually give them the activity. So these are just different types of assessment that you can use for stage 2. And then stage 3, of course, is the planning. So after you have already did stage 1 where you want the desired result, and then you already did stage 2, you assess them. Now it's time to do stage 3. Stage 3 is actually the planning, the part that you, as a teacher, what kind of activities you want them to do based on stage 1 and stage 2. So in this case, the learning plan, what I chose was students will take notes in their journal. For example, a formula for the area of a trapezoid. Explain in the lesson by forming a parallelogram with 2 congruent trapezoid. And other types of activities that I would use in this stage is students will complete problem-solving problems. Students will analyze relationship. Graphic organizer, have students construct a 3-column table of information about the area of quadrilaterals. The first column lists names of figures, parallelogram, trapezoid, rhombus. The second column has formula for the areas. The third column shows drawing of a figure with label for their bases, heights, and diagonals. So again, these are types of instruction activity that I chose based on my desired result and assessing my students. Okay, so I think these activities will enhance the desired outcome that I want the students to have. So as you can see, we already went over the 3 stages of backward design, and we used one of the TEKS to, as an example, to implement backward design, okay? So let's just go ahead and do a quick recap of what backward design is. Why should we use it, okay? Backward design is an effective way of providing guidance for instructions and designing lesson units of course, okay? So we want to start from the end first, the end product. What is the desired outcome that we want, and work our way up to the activity, where we're used to doing the activity first and then assessing later, okay? So in this case, backward design, there's 3 stages. You start with the desired result, then the assessment evidence, and the learning plan. Okay, and that's it for today's training. If you have any questions, feel free to come and ask me. We're going to go ahead and practice with another math TEKS today. Using one of your 6th grade math TEKS, let's go ahead and try to use backward design and implement a lesson. Thank you, guys.